All right. So let's start, right? So here's what we're looking at. Right. We're going to take a look firstly before we jump into right angle triangles. We're going to take a look at the types of triangles. All right. Anybody can list out the types of triangles?
Isosceles, equilateral.
Right. So let's take a look at here. Wait, sorry, I wasn't listening. Sorry about that.
No.
Let's take a look at types of triangles. So can you go back? I had nothing there, Shannon. Right, no, I'm now starting tricks. I didn't do anything. I was just telling you the topic to do next. All right, so we're looking at types of triangles. So there are two main types that you could break it down.
Right angle.
Right, yes. So you could break it up into these two here. You could break it up into right angle triangles. Right? Let's do a quick little example here. Right angle triangle looks something like this. Right? Watch this here. If you look at it there, right? The 90 degrees here. Are you okay with that? Yeah. Opposite the 90 degrees is what we call the hypotenuse. I don't want to spell it wrong, so I put HYP. Right? Right? Opposite the 90 degree, which is here, right? The 90 degrees there, and opposite is the longest side called the hypotenuse. Right? If I were to make this angle here theta, right? You're right. Opposite is here. This is the opposite. And here is your adjacent. Right, the adjacent is the one that helps make the angle.
But it won't be right angle and the angle on the same line.
The one with the right angle and the
angle on the same line.
But if I change theta up here,
then it will be where
on the next side. All right, I understand what you're saying. Yeah, that's right. The opposite the right angle is a hypotenuse, and the adjacent helps make the angle. Right? Anyone that helps you work out. Right, so if your angle is here, opposite is here, right? Right, of course, we should know that hypotenuse is the what?
Long term.
Right, this is the longest side. Right, this is the longest side. All right, so that's the first type of triangle. Then you have your non-right angle triangle. Right, I want to show you something with the labeling to make sure you understand how we label up non-right angle triangles, right? Right, watch this here. When you're labeling, right, angles get capital letters, lengths get common letters, right? So watch this here. If here's capital A, then opposite that length is a common E, right? If here's capital B, opposite that angle is your length, common B, right? If here is your capital C or uppercase C, then opposite is your lowercase c, right? So lengths, common letters, angles, capital letters. All right, So these are the two types of triangles that we're going to focus on: right angle, non-right angle. Right, ready? Let's focus on rules that control right angle triangles. All right. Non-right angle is the more challenging one. We'll do that later on. Let's focus on right angle triangles.
The non-right angle is when you can
Sine and cosine. Actually, you could use sine and cosine for everything. Sine, cos, tan, right angle, non-right angle. I'll show you all how to do that, right? But let's focus on right angle triangles, right? So draw a quick right angle triangle there. Right, let's see here theta. Here's the hypotenuse. Here's the opposite. Here's the adjacent. Right? So we need the rules that control it. All right. You see? Right, so we need the rules that control them. The first rule, right? The first rule is called Pythagorean theorem, right? I'll put it in red, right? Right? Pythagorean theorem. And this rule basically says that hypotenuse squared is equal to opposite squared plus adjacent squared. So if you take all the lengths and put them into that formula, right, it should hold once it's a right angle triangle, right? So we're going to spend some time on this first rule here. All right, so suppose I gave you a problem like this, right? I gave you a right angle triangle. Let's say I gave you a right angle triangle, right? And the right angle triangle had size pi, 4, and x. And I asked you to find it. Right? First thing is what? First thing, we have to check and see what type of triangle it is. Right? What type of triangle is that? Right angle, right? Right angle triangle. So that means that since a right angle triangle, we know that hypotenuse squared is equal to opposite squared plus adjacent squared, right? Since it's a right angle triangle, we know those rules will hold, right? Now, what's the hypotenuse? The hypotenuse is? What's the opposite? It don't really matter for now because I didn't give you the angle, but let's use 4, right? And then adjacent is x squared. What do we need now? We need to make x the subject of the formula, right? Right. If you look back at the rules I gave you last week, switch the 4 squared and x squared with the 5 squared. Whatever you want to find, put it on the left side. Right? And then make x squared the subject of the formula. X squared is 5 squared minus 4 squared. X squared is what? 25 minus 16. X squared is equal to 9. When you carry across squared, what you get? So x is the square root of 9, which is 3. Right. Remember the square root of 9 is plus 3 and minus 3, right? But we don't need the We don't need the minus because that's not valid here. So therefore, x is 3. Any questions online, Olia? Any questions there? So there are some numbers I want you to learn off, right? Well, at least when you see them, you know. If you all look there, you're seeing 5 and 4, right? 5, 4, and then when you add in the 3, right? That's a Pythagorean triple. So these numbers always go together. Once it's a right angle triangle and you see 5 and 4, the last number is 3, right? So I want to give you some numbers to learn. So you